you were to launch launch a product, what could you support at the end of the day? There's the business model. Are you a diversification, unification model? What is your operational mode? And tying it to that, you don't want to do something that is so abstracted from what you do in core business that it becomes distractive and disruptive to your business. Customer demands, what are they looking for? What do your competitors have? Those are key things that you need to ask when you start looking at what exactly do I want to build? What net effect do I want to create at the end of the day? Is it ROI? Is it better customer satisfaction? Some of the things that Steph touched on. What else? Anything else you can think of on why you would want to build a solution? Thinking hardware, software, total solution, soup to nuts. What do you think people would want? Make life easier. Yeah, exactly. So if they had more information, they could automate more things. Yeah, very true. Yeah, so we see that a lot. Actually, that's one of the highest ROIs, the trivial things. So if you don't know what's happening out 10 miles away at a site, off-site, so you send a guy in a truck, and you're paying that guy so much an hour, and you're paying so much for that truck, and you're paying so. If you knew what was happening out there, over the internet, you could bring it back into a backend system or a cloud-based system, visualize that data, and actually extract the value of that. So it's a pretty big ROI on that. So the planning, on the building is very big. Many times we'll go into a conversation and we'll get past that concept. I've got this idea of what I want to build. One of the first questions I have is, what are the marketing requirements? From an engineering standpoint, what are the marketing requirements to back into the technical specifications? What are the use cases? That lets me know have you actually done a business plan to put this together? Because there has to be solid business logic behind any solution you bring to market. Otherwise, it just doesn't work. Just the cool factor won't do well outside of some of the group funding. So the budget versus cost. You really have to plan this out. What are you anticipating the value to be? What do you anticipate the cost to be? Looking at all of those things, is this something strategically you want to pursue as a company? Life expectancy, the future proofing of it. So if you're looking for something that has an economic useful life of 2 years, you would probably look at maybe a current technology or very mature technology that's lower cost. But if you're looking at something that's maybe 5 to 7, 10 years out, you'll want to look to a technology that is going to have longevity to it. It's going to future-proof your solution into greater detail. We'll talk about network, the network longevity and some of the technology and longevity with that. Scalability. I've run into a lot of situations where they think, I can support this up to X amount, or my infrastructure can support this. Or they are looking at maybe a technology like Wi-Fi or Bluetooth. And when you start looking at deploying that and introducing user error, into the equation where it doesn't need to be, you're introducing actually faults and things into an equation that don't need to necessarily be there. You look at how you can scale and deploy tens, thousands, up to millions of devices. I think there's a pretty strong case for what cellular can do in that space. The time to market, how do you reduce it? When we look over at that table over there, there's a lot of pieces. Brandon is here from NimbleLink. Brandon, if you raise your hand. So NimbleLink is a manufacturer based out of Minneapolis that does a pre-certified socket modem that plugs in, via an XP form factor, very small form factor, very good, embedded modem solution. So if you want to get to market rather quickly, spin a board quickly, not have to go through certification, that's really what that is. So your time to market becomes crucial. Do you need to do a proof of concept and roll something very quickly? You can do it that way and get there. Your global deployment is another piece. Are you looking globally or are you looking domestic? Those are some of the questions that you have to ask, because that determines your technology. And it also kind of determines what you do for an infrastructure from a software standpoint. You're probably going to look at using multiple data centers because of latency, and also the sovereignty of data within countries becomes important when we start looking global. So security, this is a big one. You hear about cars getting hijacked with their Wi-Fi. They don't have any infrastructure on the backside. So how do you build security in depth or defense in depth in IoT? That becomes a big question. There are a lot of tools that you can put into place that I think we'll touch on many of these today in the talk track, but that's definitely a consideration that has to be baked in. It can't be bolted on. You have to think about it from the get-go. What are you going to do to address the security risks? And anything that you do out there, the reality is you deploy an IoT solution, that becomes a new threat vector. That becomes your new corporate boundary. So most people don't consider that. They think it's ancillary, it's not going to impact, but it is a threat vector that you have to address at some point in time, or have it tied down so that people cannot get to that or get to your infrastructure through that endpoint. So what else, what other considerations when you're looking at this planning stage? What else can you think of that you might want to include on this list?
Just out of curiosity, how many of you either have customers that are global or looking at marketing something to outside of the United States? Okay, a few of you. So it's a good topic to bring up.
Yeah.
The hardware component.
Oh, absolutely. And we always say it's hardware, but a solution it's really a collection of core competencies. You take your hardware that is one core, and your firmware that is on that, and then your software that creates the value at the end of the day. It allows you to visualize and take that abstracted data in putting it into a meaningful context. So I love it that we have kind of a mix of people here, that are software, hardware, whatever interest level it is. IoT is really kind of a holistic picture of all of those things working together to make sense and to pull in other data into it. IoT is really that flattening event of data where you can put it into a horizontal context and derive greater value from it. So that's one of the things that excites me about the space. So we talked a little bit about longevity. So who here has heard of network sunsets? People turning down 2G, 3G networks. Yep. So made big news a few years ago, and some of our network competitors are going through that right now. Refarming, just our insatiable appetite for unstructured data, video, pictures, all of those things have created the need to take spectrum holdings that were previously dedicated to legacy technologies and refarm those to LTE. Verizon's been very lucky in that space. We actually invested very heavily early on in spectrum leases. So we had a lot of spectrum, additional spectrum. So we're able to commit to our customers that through the end of the decade, we will keep in the same or better state our CDMA network. So that's your 2G, 3G. So you'll hear it referred to as 1xRTT or EVDO. 4G, of course, is the future, LTE. That's long-term evolution, if you're not familiar with that. So what's in your cell phone today is probably a Category 3 or Category 4 LTE, what they refer to. And that really denotes the specification of that. So like a phone, it has a theoretical capability of 100 megabits of data down in the downstream and 50 megabits on the upstream. When we look to IoT or machine-to-machine or a solution that uses very little data, it's significant overkill. You don't need that type of speed. You don't need real-time access. You don't have a real-time application. So when we look at the next iteration, this was actually part of the original specification in 2008 for LTE. So 4G LTE, the Cat 1. Has anybody heard of Category 1 LTE? Perfect. So that is a move from, to about a 50% less complex, from a module standpoint. So in the data throughput is about 10%. It's 10 megabit down, 5 megabit up, theoretical. So probably closer to what you would see in a 3G type of speed. It's constricted from a data standpoint. We really don't want to see a ton of data. Optimally, more like a telematics type of engagement where you're sending data back from, say, an engine or sensor array back to a backend system or cloud. So this is lower data consumption, but that is the future. So how would you migrate, to a new technology? When you look at the end of networks, the legacy networks, CDMA, moving to LTE, that has a very, very long lifespan, talking into the late 20s. Possibly into the 30s, that technology will be viable.
Really quick.
Yeah.
So most of the telemetry machine-to-machine devices that are out there today, would you say
They are.
network?
They are.
Okay.
It's a low cost of entry. The nice thing about this, when we started looking at 4G LTE Cat 1, it actually is about at parity with the cost of a module that is a 2G module. So if you wanted to develop for LTE, the module cost is about the same. Certification cost is a little bit different. We'll cover that a little bit later on in the slides. But that is coming down as well. We're working to reduce test cases for machine-to-machine IoT to get it to a reasonable level. So when you're planning, do you want to build it or do you want to buy it? Oh, question, yes.
So just a quick question. So like,
Yeah.
my background, one of those like software folks that this whole conversation is new to me. When you're talking about costs, I work with a lot of startups in the area. Can you kind of share like what some of those numbers are, like as you're going through it, like some of the certification costs?
Yeah.
Monthly costs. Like, as you're
Yeah.
these modems, like just to give me kind of like some sort of picture.
Yeah, that's a 1 million. No, just kidding. No, that, yeah, and we'll cover that a little bit, the cost of certification and kind of the endpoint cost. Everything is coming down. I mean, everything follows, when you look at it, IT in general, everything is following Moore's law. Everything is getting halved and halved and halved, but things are getting faster and faster and faster. So it's an exciting time to be in this space because that means you can connect more things for the same amount of money. So,
I think that's what we're really seeing
Yeah.
the network, how everyone would go through, they needed that small amount of data to go through the 2G, 3G and certify on that, but then it became an issue of, okay, we've committed to having that network up through the end of the decade, but what happens now? I need to build something that's gonna last 10 years. I don't need the speed that LTE 4G has, which is why when Cat 1 came out, that cost drastically reduced, so it really fed to that space for our intent customers. And I know that there's some info in here.
yeah, no, absolutely. So referring back to the table and to Brandon too, because this becomes an important conversation you need to have internally. What is your deployment structure? Do you want to build something, a module down design, and go through that and go through the certification process, or do you want to get to market rather quickly, build something, plug it in, or are you going to look to an external device? Do you just need USB access, which there are a number of devices that do that as well. When we look at the modules, there are different form factors, different arrays, different configurations. You're going to see, a couple of them are board-to-board. Those are more legacy type of connectors. A lot of them will be M.2 or mini PCIe. Some will. Most of them are going to be surface mount. So do you want to go through that surface mount process? Do you have enough volume to offset what your NRE is on the front end? Do you have enough volume at the end of the day for that to make financial sense? And that's one of the things that we sit down and work through many times with our customers. What is the most viable path for you to pursue when you start looking at cellular, if you want to embed it into a current system or new system? So here's kind of a breakdown on the hardware options. So we usually look at these volumes, 10 to 500. You probably want to buy something. You probably want to buy something off the shelf. It's pre-built, ready to go. Fits your use case to a point that you wouldn't look at building something. The next would be the embedded modem. With the embedded modem, you're going to have a little more cost. You're going to have to build a PCB or respin what you have because you're going to have to create traces and access and supply power to that embedded modem. So this is cost per unit, 800 to 200. Now that is in probably quantities of one many times. So in larger quantities, that price goes down. But this can get you to market in weeks. The time in production is maybe 3 months. That's pretty typical for what we see. It's a very good way to pursue. When we look at doing the module down design, these have really dropped through the floor. This used to be about 30, 40 grand a few years back, for a 1X RTT. So something that is very, very exceptionally slow by our standards today would have cost a mint just a few years back. Same thing with EVDO. The 3G would fall back to 2G, very expensive. LTE, this actually has gone through a price drop now too. What we're seeing now with Cat 1 has impacted the pricing of some of the other volume of LTE testing. So we've reduced the test cases for IoT down to about 20 to 30,000 at this point. So It's very good from that standpoint, but 5,000 to 6,000, that's probably down to 4 to 5 now. We keep on reducing the test cases. We keep on seeing the prices lower. Things are making it through the labs faster, reduces the cost to the developer at the end. But you have to have pretty high volume to offset this. This doesn't include what you paid the engineer to develop your board. This doesn't include what you paid for that production run for your pilot. So you have to have pretty good volume and pretty good opportunity to pursue that.
And just a note with full disclosure, Verizon does not carry this stuff in our inventory.
No.
The reason we're giving you ranges is because you need to work directly with the OEM, module manufacturer, etc. But the great thing about working with Verizon on some of this stuff is that we have a very large partner portfolio and can help put you in touch with the right people that can get you some quotes on some of this hardware, as well as the certifications.
And the best thing about it is if you take the right-hand side of this, that's what we charge you. We don't charge. We're a free resource, so if you have questions, you need answers, you come to us. That Verizon provides us to the market for that, to help you and assist you as you build things and go forward. So this is the eye chart. Other things to consider. So there will be a test later. After the intermission, so steady up. But these are some of the other questions that you're going to want to look at. What environment are you going to operate that in? Does it have specific use cases for that? Or the domestic versus global? Is it North America or is it all of the world? The form factor, how large of a module can you stand? How large of an embedded modem do you want to utilize? The bandwidth and data management. We'll talk a little bit more about this when we start looking at how you thin out data levels. So the protocols you choose from both an application and transport standpoint, those matter. Are you going to manufacture it in-house? Are you going to outsource? Now, the feature requirements, are you going to have GPS on board? Are you looking for it integrated into the cellular module, or do you want to have it separate? What other radios are you looking at integrating? There's a lot of buzz around new and different radios. And the wireless sensor network, I think, is going to explode as far as an industry and sending that data back to a common gateway or sending it back to centralized gateways along a course. And how are you going to take advantage of that with cellular backhaul? And there's some other things that are impacting or impending. One of the things we didn't talk about on the network slide, before we get too far down the road, what happens after Category 1? So down the road, there's a specification that's going out before the standards body, the 3GPP. It's called Category M or MTC. It's part of Rev 13. So once we have that, MTC stands for Machine Type Communication. It's actually a segregation of networks, so it's dedicated frequency that goes to machine. It's a 1 megabit up, 1 megabit down theoretical throughput. The huge thing is the power saving mode of the modules that they're specifying. The other piece is being segregated. It becomes hopefully lower cost. Some of the things that we see from a module standpoint, it's another 50% less complex than Cat 1. They're talking $8 to $12, possibly as low as $6 for modules, depending on the volume. We're looking at certification costs that are kind of at parity with what we saw for 2G and 3G. That's where we're looking to go to. So that's going to change everything, I think, when we start looking at having a scalable solution that you can secure, that you can do all of these things with, and being pretty much at parity with other RF technology from a module standpoint. So it's going to get very interesting very quickly. So then that's probably about 18 to 24 months out. So this brings us up to the beer break. So the break has concluded, but I think there's still beer for afterwards. So proof of concept. This is one of the stages we get to. When we start looking at that, it's going to be ugly. It's not going to be pretty. It's going to be a functional design of what you want to have. So it's proving out that use case, proving out that you can develop something. You want to get it on the cellular network. What's the easiest way to do that? What's the fastest way to do that? And perform those basic functions. Maybe you want to get buy-in from leadership, or you want to get funding. You want to have something that you can go and say, here it is, this is my idea, this is how we're going to build it, how we're going to get it done. But it's not going to be a finished design. It's probably going to be just an open, probably a dev board, might be a single spin of a board, but it's not going to be the end result. One once you have that support, you're good to move forward. But until you have that, usually it's a pet project. So what other things can you think of?
So I guess my question is for a proof of concept. I know some
Yep.
companies, when developers are developing their hardware, companies will actually provide either the module or whatever,
Yep.
an assurance that they're going to get a lot of other modules or services
Yep.
sent off. Do cell phone networks like Verizon do the same thing?
Well, we don't manufacture any modules. Oh, yeah. Well,
Developers.
sometimes it depends. Sometimes there are seeding functions, but typically at high volumes, high volume commitments, that's when we start seeing dollars start being distributed back for that. There are a lot of startups, especially today. There's a lot of innovation. I love it, but I always kind of characterize all of the startup movement and IoT, and because there are a lot of things that are built out there that if they build them are going to be very cool. But it's kind of like my swimming ability. There's a lot of motion. It's just not a lot of forward. So, I would drown if I ever ended up in a river without an inner tube. So, the problem with it is having so many people that are chasing it, having so many people that are interested. We found companies are starting to pull back a little bit actually and say, hey, show me what you're going to do. Show me a volume commitment. Show me your business plan before they're going to commit resources back to you. It's not unheard of that they will, but it's not common anymore that they're just going to open up the floodgates of free stuff. So any other thoughts on what you would think from a proof of concept?
No, but just to piggyback on that, a lot of the discussions that I'm having around that type of information with startups in particular, it's my job to educate those individuals and our customers on our partnerships, our resources. So utilize us as such, and we can help bring those individuals in and engage those resources to help get you there faster without you guys having to do all the groundwork on your own.
All right. So development kits, so a couple of different things here. So one is a development kit that utilizes kind of that pre-certified modem. The other one is a module evaluation kit. So there's two uniquely different things. When we start looking at proof of concept, so the one on the top side, that's going to have a microcontroller, whether it's 32-bit or 8-bit or even a 16-bit. No matter what it is, you're going to be able to program to that. You're going to be able to pull in I/O, whether it's digital or analog, and pull in sensor data and create that full proof of concept. Now, when we look at the one below, which is more of a module application or a module evaluation kit, that's more testing the functionality of that module, making sure it fits the use case that you have built out. Does it have all of the feature functionality that you want? Is all of the I/O exposed that you need from the module? Does it have those capabilities? So those are going to be important distinctions, and that's one of the things that we can assist with as well. Are you better served to spend the money on a module evaluation kit, which is somewhat expensive, or go the more cost-effective route, and one that gets you a lot of data that you may need for that senior leadership buy-in. Prototyping, my favorite thing. So half of my family room is now dedicated to prototyping. So,
Kids on board.
yeah, my wife and friends tell me I'm raising nerds. But it's okay. I'll take it. So custom board design. Yeah, I came home with a PCB router after the last bonus, and she said, "What are you doing?" And so I said, "Well, I bought something. I found a deal." So it was on sale. So I'm kind of a disturbed hobbyist. Not only do I do this for work, but I'm a very big enthusiast. I love to build things with my kids at home. So it's a lot of fun. But so we're looking here at custom board design. So you need somebody with RF engineering experience. Typically depending on what you're wanting to build and how you're building it. Module experience. That future proofing piece of it, which we talked about. One of the other things I wanted to hit on too, when we start looking at pre-certified embedded modems, there's a higher cost to it because the engineering's been done, everything's been vetted out. But with that premium comes the ability to be modular. So when we talk about future-proofing end-of-life on networks, you're able to pop in a new technology, not have to respin a board. You're able to update your firmware, not necessarily throw that PCB away. So it becomes a unique value and a unique value proposition of employing those. And that's another reason that we talked about what kind of that break-even point of module down versus embedded modem. That increases that also because there's a higher value associated with modularity. We've seen that from some use cases as well. Power management. So are you going to have power where you're going to locate it? Is it going to be in the middle of nowhere with nothing? Are you going to do some sort of energy harvesting? Is it going to be solar? Is it going to be motion activated? Is there going to be temperature differential generation of electricity, that thermoelectric generation? Micro generation with a little, I saw a design with a little windmill on it. So as you're going down the road, when the truck hits 45 miles an hour, the little turbine kicks in and actually recharges your battery for a telematics application. Same thing with the data usage. That has to be a consideration at this point. We start thinking prototype. We start thinking that relevant data that we want to bring back into a back-end system. How are we transmitting it? Does it need to be always reliable? Does it need to be somewhat reliable, or can it be best efforts? What's going to give you the best value for your investment and what you're going to spend to support that solution going forward. Firmware strategy, very important. How are you going to update it when it's in the field? How are you going to reach out to that device and make sure that it has the latest and greatest? Or if you want to push a modification, how is that going to get accomplished? Is it going to necessarily self-heal from a architectural standpoint within the software? How are you going to build that? I know a lot of, from taking a poll of the room, a lot of people I'm assuming more on the application development side. Are there any embedded engineer? Like embedded, okay. Yeah, so when we look at that, we call that, fun with a capital F. When we get to the firmware, that's Inspire. But firmware is its own unique animal at times, and it depends on what you want to use. I mean, are you going specific? Are you going to employ something that's readily available, C, C++, or is it going to be a custom real-time operating system that you're going to employ in there? It really depends on the end use case and what strategy you employ. What other things can you think of that are going to be important at this phase when we start looking at that kind of line items? Anything else you can think of that you would want to include at that point? Yes. Yep. Environmental. So your enclosure. Yeah. That becomes uniquely important. Aesthetic as well as functional. So does it need to be IP rated? Well, Ben laughs and snickers, but does it have to be pretty? And at this point, yes, it does. So when we're at this stage of it, we're no longer making a proof of concept that can just be wires sticking out of a breadboard hooked into things, which I've done plenty of those. It has to be at this point something that you could go to market with, something that you could attract investors. Yes.
How many folks do you see that you've worked with that have got to this prototyping phase that really haven't gone through like the customer validation point? Like, do you expect most of the folks that you work with to have already validated their concept and understand their target customer?
I would like them to have done that really prior to buying anything and investing a lot of time. It needs to be vetted out. The business case has to be there. I say this time and time again in my role at Verizon and in others, in a lot of the meetups that I attend and that I organize. There always has to be some function, some improvement tied to that. It doesn't have to be a monetary ROI, but there has to be an ROI. It can't just be for the sake of and be successful or be widely deployed. So from a B2B standpoint, of course, yes, it does have to be tied to some level of self-improvement for the company that it's being built for. But if they haven't done that at that point, I've led them astray, or I've not made it as firm of a point that there has to be a business plan in play. There has to be something tied to it. Otherwise, it's really you're looking for an investment by doing no research whatsoever. So, yep. Anything else? Any other things that you could think of that you would want to throw into this at this point? All right, moving into considerations. So when you're looking at the prototyping, how you transport the data becomes important. I said always reliable or best efforts, and there are some variations in between depending on how you employ them. But speed of transfer. So does it need to be always reliable, somewhat reliable? Does it need to be high data traffic? Those are the things you'll have to ask on this. Can it drop a few packets and it's not going to kill the end solution, essentially? Can some things get lost if there's congestion on a network and you still be okay with it? This becomes important when we start looking at overhead. So this type of scenario where you're sending a 105 byte payload every 4 minutes, minimal data. We're talking sensor readings with headers, essentially. Maybe a GPS coordinate and a few sensor readings. With every 4 minutes, that calculates into a lot of times per month. We start looking at what does that mean at the end. 105 bytes compiled into a monthly, about 1.5 megabytes per month, which isn't bad. 3 megabytes higher for TCP, so that's all overhead. But if you need that reliability, if it has to be, there are ways that you can architect it so that maybe you don't have to send every 4 minutes. Maybe you only create from a firmware strategy standpoint, it's exception based. If it falls outside of parameters X and Y, then you trigger an alert. Otherwise, you just log the data and send once a day. So you're only paying for the overhead one time, but it's a much larger data session. But it's always reliable data at that point. If you need reports every minute or every 2 minutes, every 5 minutes, sometimes UDP is fine, because if you miss that data set, it's not going to skew what you have at the end. You're probably going to have a full enough set of data to fulfill what your end goal is, what you want to accomplish. So those are considerations. Let me go back to this. One of the other things over the top of this, the application protocol. So if you're looking at coming from a wired environment and you're saying, I can use RESTful APIs or a RESTful API. I can do the get, post, put, delete over HTTP. Please don't. We find time and time again that using something that's thinner, that's purpose-built, is usually a better way to do that, unless you're doing that kind of log drop session at the end of a day or end of a period of time. HTTP is awesome across wireline, and if you're using HTTPS for that security factor, it's great. But if you can do something like CoAP, which is the constrained application protocol, built for those environments. When we start looking at TCP, MQTT becomes important, the multiple queue telemetry transport. That's important. It's kind of that pub sub, but it's very thin over the top side of it. Provides that reliability you wouldn't have to have with HTTP. Same thing with when we start looking at CoAP over UDP, very thin. I think it's 8 bytes on the header size, but it gives you some additional functionality. It gives you the ability to take UDP and say, did I receive that entire checksum at the other end from a header standpoint? If I didn't, can you resend the packet? You can send back, you can kind of validate from that point. So that becomes an important consideration when you're architecting. Oh, yeah, go ahead.
Do you know what kind of frame size we're dealing with when we're talking about wireless layers?
Like a maximum transmission unit, you mean, or?
Yes.
Yeah. So, it's normal MTU, 1500. But if you're putting like essentially any security on that, you're probably going to want to back it off to about 1430 bytes. So regular segmentation like you would over any IP network. But once we start looking at an IPsec tunnel, if you're going to secure it, and we'll talk about that in a little bit with security, you're going to have to drop that down a little bit. It's going to impact your MTU a little bit, but you can set that from the device or set that from a network standpoint at the switches, depending on what you want to implement. IPsec is going to take up about 56 bytes per session. So you want to account for that and probably reduce your MTU. Yeah, we actually ran into an issue at one point where it wasn't segmenting. Yeah, yeah.
Are you going to to talk about IP4.6 and, you know, how the explosion of devices and
The IPv6, transformation, because right now everything, the world is still running IPv4, but everything on the backdrop is starting to go 6 low pan and IPv6 for that. Not necessarily in the cellular world. Eventually it will be there, but I think we're waiting for wider adoption of it before we'll roll it out. Internally, we run more from an IPv6 standpoint, but the rest of the world is IPv4, so we NAT it back out many times. So it's not native. We wouldn't be able to use that in a real world environment at this point. You can only use it on closed loop networks. So wireless sensor networks are great for 6 low pan or IPv6. So you look at LoRa, you look at Zigbee even, and the Bluetooth in the 4.1 spec. It's you can actually go 6 low pan or IPv6 with Bluetooth low energy now. So I mean that's an exciting thing. They still haven't figured out meshing, but they figured out that piece. So you have an addressable system with a modulating MAC address, so people can't eavesdrop as easily with like the 4.1 spec. So I mean we're seeing some movement that way, but it's not widespread, and it's not, the internet hasn't gone IPv6 yet, even though we're out of addresses. But I think we will see that come to fruition. Probably, I don't know, within the next 3 years maybe we'll see that, because we're going to have to have it. Eventually it's going to have to be forced upon us that we run to an IPv6 world. So.
with a lot of times these things are reporting a fixed server.
Yep.
And your path is, tends to be, you're not reaching another endpoint usually, so.
Right.
It may be easier to migrate to that.
Yeah, well, exactly. When we start talking trillions of IP addresses and being able to hop back or daisy chain back across, mesh networks, I think that's where it becomes uniquely useful. And especially if you look at a closed loop system and being able to employ that. So I think that's going to be very exciting. So Verizon Innovation Program. Verizon actually runs a couple of innovation centers, one in Waltham, Massachusetts, one in San Francisco. So San Francisco's got a great view from the deck. I would highly recommend that one. So this allows you to come in, look at devices that are being developed, mostly LTE, the most cutting edge things, looking at air quality, some of the other aspects of development, really cutting edge, working with the engineers. So the engineers from Alcatel-Lucent, Ericsson, they're housed at those facilities. So if you have questions about network and network operations, future evolutions, they're great people to bounce it off of. So it's just a neat experience for people who want to go in and have a granular discussion, but also have a thought-provoking tour and discussion and engage with other engineers. So it's a nice thing that we've put together for that. So this is the production launch it thing. So when we go to production, this is test it, certify it, launch it, manage it, support it. So like I said, there will be a quiz later. This is your certifications. FCC, which is your specific absorption rates, making sure that you're not making people glow. Carrier certifications, data security, we'll hit on that. The manufacturing, so how are you going to manufacture that device? Who's going to do your enclosure? Who's going to spin your boards? Who's going to provide that? The automatic provisioning, so API sets and different things that you all work with, from a software standpoint. How does that fit into this? Technical support, and there are always other things. What else can you think of that you would want to look at from a production when you're going to launch and you're going to market with this?
Documentation.
Yeah, documentation, absolutely. Making sure that you have everything set, so when you do ship it, you don't have to take a phone call every time. Yeah, that's definitely consideration.
Another one would be billing. We had
Yes.
a conversation over here.
Yeah.
You're going from, if you're a company that's manufacturing something, now you're going to manufacturing service. I've never billed a customer annually or biannually or monthly before. What does that look like? And I think that's something.
Yeah, absolutely, absolutely.
Defects and how to take care of warranties.
Oh yeah, RMA is huge. Warranty and returns, absolutely. You have to have that structure in play. That's why that business plan, thinking it all the way through, is so important. So this is welcome Brandon Hart. Brandon's actually a former coworker of mine, so we left him on here. So yeah, he's immortalized on this. So this is what our open development looks like. If you want to do a module down type of design, this is a portal that you would see once you get to that level that you want to build and you want to certify. We would start working through this particular set of, I guess, test criteria. Would be probably the best way to put it. So you register the device. This is kind of the progression of certification. So device lockdown call, the DLD, testing authorization. It's in testing, the post results, test pass, and device pass. In a 2G and 3G device, this can take 2 to 3 days. To get through testing, and to get reviewed would be another 2 to 3 days, and to get to certification, maybe another 2 or 3 days. It's very quick anymore. Once we have the test results back from the lab, it usually flies through. 4G LTE sometimes takes a little bit longer, depending on what you run into at the lab. Are there any failures or any things that require retesting at that point? So sometimes it does take longer, and if you have additional radios involved in the process. So there is a whole set of requirement and test plan documentation that's out there. There is what's called a test entry checklist criteria checklist. Sorry, I just got it backwards. That document will define what the labs need to test for, and that will define what tests are engaged and what the cost will be. So that's what they'll quote off of. They'll look at what does the device entail, how many tests do I have to do, and that's what really determines your lab time, determines your cost. So we've significantly reduced it and plan to reduce it even further. But at this point, the kind of the cost that I gave, the general values, kind of where that's at, but anticipate those to actually decline.
So on this table back here, there is the machine-to-machine device OEM starter kit. It has a lot more detail around the open development initiative, specifically the portal and the different steps that you take from ideation all the way through to certification. As well on the back has the links to where to go to this site, as well as some of the other links that Jon mentioned. So I would recommend grabbing one of these.
And that little pamphlet also has our 6 approved test labs. So all 6 of the labs can do LTE certification. 4 of them can do CDMA, so the 2G and 3G certification. So, but those labs are listed on there, and I think there are links to their websites as well. A lot of good resources in that particular little book. Any questions on this? This is something that you would, if you engage in it, we would do a walkthrough of the site. So it probably will go a little bit slower than me clicking through. But
please know at this point that you are going to have an NDA between yourself and Verizon, so your information is proprietary.
Yeah. So private network. When we talk about security, so one of the ways you can accomplish that, and some people refer to this as security through obscurity. It is, but it isn't. So what we do with private network is we take whatever your termination point is. If you want to go to the cloud, if you want to go to a backend system, we'll take from that server that you're terminating to, take subnet of private IP space that you're not utilizing anywhere else within your routing infrastructure, extend that out to the devices either static or dynamically. So that gives you the ability for bidirectional communication. So you can have mobile originated or mobile terminated communication. So bidirectional, and also an IPsec tunnel with geographic diversity. So we have from one data center, over in one side of the country or one in the middle of the country, coming into your backend system. So there's geographic redundancy. In case one fails, one will fail over. Primary and secondary tunnels. That all comes back into the backend system, which can be cloud. It can be your back office. It can be your home computer. If you have the proper infrastructure, we will terminate that IPsec tunnel to you. So it never traverses an untrusted network with your data. You can't hack a private IP address because you can't see it. So that becomes very important when you're looking at deployment. Everything that's out there, even if it is a dynamic public, it's NATed off of something. Even if it's NATed IPv6, you can still find a way back to that device. And hackers do. We see it all the time. We see a lot of traffic from China. We see a lot of traffic from other countries that are engaged in state-sponsored hacking, and people that are bored. We say that a lot. So Sometimes it is inadvertent data consumption. Problem is when somebody starts a denial of service or distributed denial of service, attacking an IP address, trying to get to the back end of that system, that's billable data on any network, one cellular. So when we start looking at that, you want to get to a point where they can't see you, they can't hack you, they can't send a distributed denial of service attack to you. You no longer have a threat vector. So that's why this is important. So any questions around how this operates at all? I know there's still beer left, so I don't expect many questions. All right. So when we start looking at how we manage devices in the field, this becomes important as well. We offer with that private network what we call machine-to-machine management center, which is it's a free service. It's a portal that you can go to, which gives you a device list. It'll list the status, alarm status. You can set alerts, thresholds, do reporting out of this feature, so you know what those devices are doing in the field. What's the last time they connected to the network? How much data did it consume in a period of time? Did something go rogue? You can set a threshold and shut that device off before you incur a large overage. So this becomes uniquely useful, especially when you take this from an API standpoint. Integrate that into your system, integrate that across into your backend or your extranet or intranet. You can manage the devices, the connectivity remotely using this. You don't have to log into a portal or switch between screens. You don't have to be on a swivel. You can have it all in one location through the APIs.
Can you talk about that API? Do you know what
Yeah.
kind of APIs are available?
Yep. SOAP XML available today. In about probably towards the end of Q2, we'll have what we call ThingSpace Manage, which there's ThingSpace Develop right now. If you look at Verizon, we're kind of transferring over. We have a portal called ThingSpace. So eventually you'll be able to actually abstract data from there. At this point, it's going to be managed. There'll be a RESTful set of APIs with some additional functionality as well. But with an NDA in place, you can have access to the SDK as well. So where this becomes important with the APIs, when we start looking at automation. So if you're going through a production line and say you have a barcoded module, it's going through and that MEID or IMEI is on that module, you can go through, scan it. Once it hits the end of that production line and hits the end of the certification testing, you can do an API call, and it will actually go through the provisioning process automatically and put that device into production state, into a deployable ready state. That becomes very important when you start looking at tens of thousands of units. You don't want to sit there and call it in every time. You don't want to upload a file every time. But if you can do an API call, it's automated, and it will validate. It will send you a callback and let you know that it was successful in its validation. Yes?
Zach's data is not actually billable at that point? It's only billable when it...
Well, it depends. There are features that we can set up to enable that, usually for OEMs. What we like to do is set up what's called a device setup feature, or we attempt to do. It depends on the size, the volume, what it is that you want. So for a period of time, we don't have to bill for data. We actually offset that, or we show it as a bill and a credit on the same invoice. But there still are a few fees that the government still wants their piece when we talk about that. But so there's still a little bit of cost, but it's called device setup feature for a reason. So that you have that time, that shelf life to get from the end of the production line to wherever it's going to be installed at the end. It gives you a period of time that automatically sets to a set plan or a set, after a set time period or at a level of data consumption. So it can be automated from that standpoint also.
Really?
Yes.
When it gets above a certain level, then it goes...
Yep. Yeah, so it's 60 kilobytes of data consumption typically. That's enough for you to send a ping out to a server, let you know that it's alive. Yeah, but it lets you know that it validated on the network, that it's service provisioned, and that it can communicate over IP. And we also, it's like up to 15 SMS messages. So if that's part of your provisioning process, you can test that as well. So yeah, nice thing. So this is only one use case for the APIs. There are many others. Lots of different things that you can do with it and fill into a backend system. This is a very limited subset of what's available. And we're to the end. Yay.